But what else? There's a couple more slides showing what we're doing, like in terms of development. Simulators, this is, I think, one of the things I'm most excited about. It'll let us do some reinforcement learning. Here, I sent Tom like 4 or 5 photos of this ADC race in Denver, sponsored by SparkFun. And then he, from those photos, created this simulator that you see on the right, with a donkey car racing around. And he's got it, it's on the donkey website, and you can download it and run your donkey autopilot against the simulator. And he's just started testing out a headless mode, which will let us sort of, train these autopilots overnight and really get some good autopilots. Yeah. So there's a lot of exciting stuff to do with simulators coming down the pipe. And just more data. One thing I'd really like to try to help the community achieve is being able to share data. Adam did an awesome job with the design of the hardware so that the camera angles are all at the same height and 15 degrees pointed down. So in theory, and actually in practice, you can share autopilots between cars. There's some difficulty because the cars will be calibrated differently, but it has worked in races before. There was the high school team at last race used one of my models and was able to get around the track. What else? Also just new tracks, new environments. I think just the behavior cloning is super flexible in the sense that it's not queuing off of a certain color or anything like that. It's just trying to learn what you did and then replicating it. Maps are really huge. I think there's potential to do visual odometry, and if you have a map of the track and you can know the turns that are coming, you're going to be able to go much faster than if you're just trying to react every 30th of a second to an image. So I think that will make the cars go much faster. And also, the network is not stateful, so every image it receives, it's just reacting. So adding an LSTM or some sort of stateful part of the network, I think will make it, will allow it to go faster, but also make it more robust so that if it sees some flash of light, it won't veer off the track. And then the next slide, one thing that I'm working on right now is I've got all this data from all these different tracks that we've driven on, and so I'm going through and sort of hand tuning a CV pilot that will give me the center lane, so that I can train a network based on the output of all those different CV parameters that I hand tune, so that I'll have a sort of a generalized net that will, you'll be able to set the car down on any track, and it'll be able to find the line without having to tune these CV parameters, like the upper and lower bound of yellow type of thing. And so on the top right, you see like a CV pilot that I've tuned that works okay, and then on the bottom, I'm using the same parameters on a different track, and it doesn't work at all. So I think finding a more general and modular net where you can plug in sort of the vision portion and it'll output where the lane is, and then you have a different portion where you have the actual control mechanisms will let us just build better pilots and experiment faster. That's most of the stuff that we're working on. And then there's in the next slide, there's just a last call to just join us. I feel like I finally found my tribe. I've been living in California for 10 years, but I feel like these are my people. It's been really fun hanging out. Yeah, I think that's pretty much it.
Yeah.
Okay, go ahead, Adam.
Yeah, so there's a couple other kind of small things. One is, please try if you're interested in doing this, please make one. If you're having a hard time finding these chassis, we're actually working on kind of a new version, which will perform better, be slightly more expensive. I'll actually hold it up. This is, it's based on a touring car chassis, so it's a much kind of lower center of gravity. Like I said, we're kind of pushing the edges of what this car can do. So it's a little bit sleeker. It's right now held together with blue tape, which of course clearly looks like this by the time we're done. And just because today is an advertisement for Fusion 360, all this is designed in Fusion 360. And since everybody else has mentioned their favorite feature, my favorite feature is the cam package. It's like a $6,000 cam package for free, so it's incredible. This new car probably will be on the order of for the base car about say about $120, $130, and then on top of that you have everything else. But it'll perform significantly better than this one. Yes, sir.
Availability?
Availability of this.
Yeah.
This one, the reason we chose it, it's based on a Tamiya chassis that they released 16 years ago, and apparently it's been cloned by every company that wants to make another one. So there's a bunch of different manufacturers, and that's why we chose it. Not because it's the best, it's actually kind of heavy, and it's got a bunch of other disadvantages about it, but it's because of availability. You can get this car in 10 different styles. And all the little pegs, which is what we really care about, are all in the same place. Yeah. Same steering, same everything. So it's a nice option. Sorry?
What's the name of it?
It's called a TT-01, TT-01, Tamiya. Like I said, it's the most knocked off car out there, I think. And actually, the other nice thing about it is most other touring cars are based on this design. So even cars that are not TT-01s often have the same configuration and layout. So, I'm hoping, I'm having some low-level issues with this, but hopefully I'll kind of document this in the next week or so, and see if I can get all that out. So, any questions?
Do you have to do a lot of soldering to get it?
Almost no soldering. So we've actually chosen the parts to keep the soldering low. While I'm sure many people in this club are fine with soldering, a lot of people are just interested in the software. So we try and make the hardware as accessible as possible and as plugged together as possible. So we've chosen the components. We use step components that require a lot of soldering. Now you can almost get away with no soldering.
What's the name of the chassis for the red car, black and red car that's on the podium right now?
Yeah, it's called the Magnet. I can't remember the
Exceed Magnet.
Exceed Magnet, yeah, is the name of the car. You can sometimes get it on Amazon. You can sometimes get it on the Exceed website. Exceed is just a badge that's thrown on by an American importer, so you can actually get it off of Taobao and other things like that if you speak Mandarin, which I don't. So, yes, sir.
What are you doing? What kind of system are you doing the training on? You're collecting the images or recording the images on Pi, and then are you doing the training for that on off-board?
Yeah, you can't train on the Pi. Well, you can't. I guess I don't know if I've ever even successfully gotten the training to start on the Pi. Maybe Will, you have. But you put it on your laptop or you put it into an Amazon instance, and you go from there.
It trains well on Amazon?
Very well. On a GPU instance, it's just night and day. It's 5 to 10 times faster.
So you have color pictures, it looks like. Are they color when they hit the CNN, or do you?
Yes.
Yes.
Yeah. So if you looked at the network, you can actually see in the network, it's 120 by 160, which I mentioned, by 3. And you can't. The Keras is super simple. It gives you a bunch of nice things. I've personally done stuff like I tried cropping first as a way to make it simpler, and that didn't no benefit, and a bunch of other things. So we're taking pictures of the ceiling and all sorts of stuff, and it still seems to work. my theory on that is that we're actually overfitting on the ceiling. I think we've actually seen some evidence of that too, and driving, and it makes for a good pilot. Good race car, not a good general driving car, of course. Any other questions? All right.
You mentioned, sorry, this is really fascinating. I don't know, I think guys are stunned by awesomeness, really.
Yeah.
And that is, you mentioned something about traction and kind of at the edge of traction and stuff like that. I mean, what are some of the directions that you want to take this besides traction to improve the whole system?
Yeah, I mean, traction is two issues. One is it's a mechanical issue, of course, and we're doing things to address the mechanical side of that with this new car, and there's other things we could do as well. Make the car lighter in certain, kind of center of gravity lower, that kind of stuff. But I think most of what we can do is in software. And Will had talked about mapping. Mapping is a key way of making this happen. Improving the reliability of our model is another thing we can do. There's just a variety of techniques. One of the other ways somebody has taken it, and actually I didn't bring the video, which I'm kicking myself about now, is by power sliding through corners. So apparently, if you train your behavioral clone net to, if you train it to power slide, it will actually power slide. So, which is fantastic.
Would the new model, would the camera be in the same position? I would assume it'd be in the same position.
Yeah, the goal is to get it as close as possible. And the mechanics are very different for the car.
Wheelbase is different. So
yeah,
the curves
exactly.
may be different.
Yeah, so the steering radius is based on wheel base.
So the picture would be the same.
The picture will be the same, but the calibration. So we could do things to help calibrate them to be the same or something like that. But initially, the goal is just get the camera in the right place. I can't remember what it is. I think it's like 70 millimeters above something. I can't remember. Anyways, there's some height that we figured out in the past.
But again, you're conscious to make it in the same place.
Yes, definitely. Yeah, and that's part of the intention of standardizing a lot of this stuff. Is that's been one of the real goals. Is to keep all the things in the same place. And with this car, as long as people are printing the same part, they're all in the same location. Any other questions? Oh, yes.
I just want to comment about traction. In the sumo robot area, the heavy-duty ones eventually went to suction traction, and they were so good you could basically put them on the ceiling and they would stay put. So you might want to think about rules to prevent that.
We can we'll think about suction traction and how we prevent that, or encourage it.
Or encourage it. You make your decision. Okay, but I just wanted to tell you.
Yeah. Actually, one of the funny things is one of the environments we're doing a lot in right now is very smooth and very dusty, and that actually, so our traction issues there are dramatically higher, and that would probably defeat the suctions. That would be
Oh, you never know.
Just the environment.
There is some. I've been working with flexible filaments a lot lately, and have been printing robot tires. There are some really interesting polymers out there now that might help with some of your traction issues.
That's good. Actually, I just got a new printhead that supports flexible, so I'll talk to you later. All right, I think that's all the questions, I believe. All right, great.
Thank you very much.
Clean up.
Yeah.
You mean like around here?
Hey, Will, thanks.
Yes.
All right, thanks, Adam.
Thank you, Will.
Thanks, guys.
Thank you.
Thanks, guys.
All right, so that concludes the formal portion of the meeting. We'll be hanging out in this room till about 10 o'clock or so when security kicks us out, and some of us even talk a little bit further out in the parking lot. So, as Wayne just mentioned, if you brought stuff, please clean up.
All the sodas, everything.
Yeah, cups, anything that you brought in needs to go out. And thanks everybody for coming. We'll see you next month.
Thank you.